So we're on 3.3, the inverse, we know that word, inverse of a quadratic function. So the inverse that we did before, so if you're thinking we did this section, inverse, we did it for a linear function. This time we're doing a quadratic function. So last time we did this, we talked about inverses, it was for linear. Now we're going to do a quadratic function. So this chapter is all about quadratics. So I want you to graph the inverse of the parabola or the inverse of the branch. This is called a branch of a parabola. So when you split it at the vertex, it's called one of the branches. And there's like the left branch and the right branch of the parabola, right? And when you split it at the vertex, you've got two branches of a parabola. So I want you to graph the inverse. So we know inverse means you are switching your x and y. So switch x and y. You're switching your x and y. So again, that's not the formal way of thinking about it, but that's what we're thinking in our heads. We're going to switch x and y. So I'm going to take these values, I'm going to write them down, and then I'm going to inverse them. Okay, so let's start with this vertex here. The vertex is at -3, 5. So make sure it's x and then y. So -3, 5. So -3, 5. That's on my original right there. This is -4, 4, right? X and then y. So -4, 4. This point here is -2, 4. So -2, 4. And then any other points that I highlighted? No, I didn't highlight any others. So you could do more, like this one here if you wanted to, but let's start with those three. Okay, I just wanted to emphasize those three so we could practice the inverse. Now, when you take the inverse, the vertex will be the vertex of your inverse. So we didn't have to do this before for linear because it was just a line. It was just going to still be a line. But the vertex here, the -3, 5, when I inverse that, I get 5, -3. So we're going to go 5, -3. 5, -3 is your still your vertex of your new inverse. So I go 5, -3 like that. So that vertex becomes the vertex of my new function or new relation. Okay, so this one becomes new here. Then the two side points will be the sides of my new relation. So this is -2, 4. So I'm going to go 4, -2, right? Switch the x and the y. So 4, -2. Okay, take this one. Let's switch that. That's 4, -4. So 4, 2, 3, 4 would be here. So you see this shape here, that little vertex shape where it goes from the side point to the vertex and around, that's now sideways. And does that make sense? Because, and I'm just going to draw that, so I'm going to grab the paper and do. Okay, that's kind of a rough one. I could do more points, but I want to show you. Now, does that make sense that that's what it looks like? Remember, the inverse is reflected in the y equals x line, right? The diagonal line. I'm going to draw y equals x. Y equals x line. The y equals x line means that the b is 0, and the slope, right? The b is 0. What's the slope? M is 1. So it's going to go up 1 over 1, up 1 over 1 like this. Okay? Up 1 over 1 the whole way, and then you can go back 1, and you can do 1, 1, 1, and it's this exact diagonal line. So we did this in, I think it was chapter 1. Oops, and I just did that wrong. I don't want a solid line, I want a dashed line. That's my fault. Okay, so can you please do a dashed line? It's not part of the graph, it's just a visual line, like you're trying to just give that. Sorry, that's me. There you go. So I want a dashed line there, and that dashed line, you don't have to draw it. So just like in chapter, whatever, I did this before, chapter 1, I think, you don't have to draw it. But look, if I was to fold it, if I was to take this here, and fold it in half, pretend I was folding the paper, right? And I was folding it right here, this would be my fold line, the crease line where I would fold it. And you see on both sides, right? It's like that butterfly. So you take it and you fold it, it's symmetrical on both sides. So if I was to extend that, they would overlap at that line, right? So these two lines here, so this is like the butterfly. It's like the butterfly wings on both sides, so it should be symmetrical. So you don't have to draw this a symmetry line here unless we ask you to, but if you want to look at it for yourself and go, oh yes, that does make sense, then you can see it's symmetrical. Yeah. We're just waiting for back, okay, again. Right, does that make sense? So that's our inverse. So it works the same way as a line, but now you can see it's got more shape to it. Now, I have some questions for you. Is the inverse of the function, this function, still a function? No, because vertical line test tells you when you draw a vertical line in your mind, you shouldn't hit it twice, so it's no longer a function. Okay, so we know that much. The line was always a function, so the line always became another line and it was a function. So when you take the inverse of a quadratic, it no longer is a function. Okay, so that's interesting to know. The other thing I wanted to look at is when I take the inverse, so let's slow this down a bit. I know that the vertex is the vertex, right? So I take the vertex and I put it over here, it's still the vertex. The left side of the parabola, is this way. Okay, so I'm going to say that's the left branch of the parabola, left branch. When I take the inverse of that, this is always going to be, so if that's negative 3, 5, this will be negative 4, 4. So that would be this side. Okay, so the left side of the parabola will be the under part. Will that always be true? So if I was drawing a parabola that was facing up, it would still be, and you would reflect it over, it would still be the underside of that parabola, of the new function. New relation. Okay? So this left side will become this left side. So let me show you. So if I had, hypothetically, okay, a parabola opening up, because people go, does it work for opening up? Say this point here was negative 3, 1. This point here would be at negative 4, 2. Right? So the left side. I take that vertex and I go 1, negative 3. That's okay? Right? So that's 1, negative 3. If I take negative 4, 2 and flip it, that would be 2, negative 4. It would be underneath. So once again, the left branch of my quadratic will be the under part of my new relation. Does that make sense? And we were going to have to memorize that because we're going to use that property later on. So it doesn't matter if it opens up or opens down, the left side always ends up being under. Because look, it goes negative 4, which makes it negative under. So my point becomes 2, negative 4. So it's underneath. Right? So it's under. That's why it heads under, because the left would go under. It goes more negative. Now, the opposite part would be true, and I'll say here, the right side, so I'll do this in the green highlighted, the right side will be the top part. Does that make sense? Because, of course, the left would be the left, and so the right side would be the top part. We're going to need that property later on. So the right side will be the top part, the left side would be the under part. And that will always be true because the left goes negative, which means that it'll go under more negative, so it'll be under. Right? And it's not because of some weird rule. It's just because the number, look, negative 4 is to the left, so this would be negative 4. It would be more negative, it would be under. Okay? So we want to know that property. That's going to help. That's going to be used later on. Okay, next one. So if I took the left side, the left branch, right, let's imagine it again. Let's draw the inverse, and you'll see it's the under part. So again, just to prove it to you. So take this value. What's this value here? This will be 3, x value first, 3, negative 5. And this one here is 2, negative 3. Is that right? So 2, negative 3. Okay, let's switch those points. So it'll be negative 5, 3. So negative 5, 3. So it'll be negative 5, 3 here. That's my vertex. Okay, that's my vertex of the new one. And then I want the left branch, so this will be 2, -3, which is -3, -3, 2. -3, 2, so it'll be -3, 2. And look, this is my vertex, so it heads towards. And can you see the symmetry line again? Right there? It's nice and symmetrical on both sides. So the left branch is the under part of my new relation. Okay. Do you recognize what function that is? This function here? Square root. So the opposite of squaring something is square root. So the left side of a quadratic would be the under part, the negative part of a square root. And we're going to match that. So we're going to do that algebraically later. So the left part is actually the negative square root. The top part is the positive square root. So this is actually a positive negative square root, two functions put together. Okay, so I need you to know left side, right side, and then kind of the y of it. Right, and we'll use that when we're doing our algebra of it. Make sense? Any questions? Okay, that's all, and then we'll do the rest next time.